Okay, so our next question is abundant number. So a abundant number is a number in which the sum of the proper factors of the number is greater than the number itself. So what I mean to say is, let me quickly delete this title, and let's say we have a number 12. Now let's try to figure out all the factors that are there. So 1 will be obvious factors, then we will have 2, then we will have 3 4s are 12, then we will have 4, then we will have 6 2s are 12, and we will again have 12 because 12 is an obvious factor. But we will not going to include this 12 factor because anything you add into 12, it will going to exceed the given number, and that's what not we want. Okay, so we'll include these numbers. Now let's try to add them. So sum will be 1 plus 2 plus 3 plus 4 plus 6. Okay, so 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, and 10 plus 6 is 16. So as you can see, the sum is exceeding the given number. So this is the abundant number. Okay, now when we try to look at 16 number, so let's say the factors are 1, then we will have 2, then we will have 4 4s are 16, then we will have directly 8. Okay, now let's try to add them together. So 2 plus 1 is 3, 3 plus 4 is 7, and 7 plus 8 is 15. So the number, the sum is less than the given number. Okay, so this is not an abundant number. Now let's try to directly write the pseudocode, because I have already told you how to grab the factors of the number, and let's try to figure out how we can do. Okay, now let's write the pseudocode here. The first thing that we will be having with us is the given number. So n equal to, let's say, 12. Now what we will do, we will initially have the sum. So sum will be 0 for the first time. Okay, now instead of 0, what we can do, we can have the sum equal to 1, because 1 is an obvious factors for every number. Okay, now we will start from directly 2. What we can do, we can have a loop starting from I equal to 2 to I equal to root n, and I am not going to tell you guys about why root n. Okay, and I have already told you in many videos that when you want to extract all the factors of a number, the end limit should be root n only. Okay, now what we can do, we can directly check if my number is divisible by the given I or not. Okay, so that is if it is divisible by 0, then that I is a factor, right? So what we can do, we can directly add this I, so s plus I, and as I told you, we can also write n by I, because if I is a factor, then n by I is also a factor of the number. That's why we are directly going up to root n. That is, let's say for 12, then we will have let's say 2 square 4, 3 square 9, 4 square 16. So somewhere around 3. So the floor value will be 3. So we will go from 2 to 3 only in our case. Okay, now we have added them together. At last, what we can check, if my sum, okay, if my sum is greater than the original number that I had. Okay, if it is so, then we can simply print out. Okay, we can simply print out that my number is an abundant number. Okay, else we can say that the number is not an abundant number. Okay, now let's try to incorporate this into actual code. So thanks for watching. Okay, now let's do the code for abundant number. Here the method is same that we used to calculate for factors of a number, that is sum of factors. And here we will do the same. I have declared a variable int number, and I am taking this number as an input from the user. I have declared a sum variable and I initialize it to 1, because we know that 1 is actually a factor of that number. So we can add directly 1 to it, and we will start from 2. So here I have started from 2. And we will not going to consider the number itself. We know that the obvious factors are 1 and the number itself, so we will not going to consider num, because in abundant number we need to check sum of the factors of a number is greater than the number itself. Okay, so if you add that number to the factors, sum of factors, it will definitely going to be greater, right? So that is not the case here. Here we will not going to take the number itself. So here I will start from 2, I'll go up to square root of number, we will calculate the factors, but here we will avoiding the same factors, that is duplicate factors. for the case of the let's say perfect number or something, perfect square. Okay, so here I'm just adding the next factor if both the factors are not same, both are different. Okay, after that I'm just going to check if my sum is greater than number. If it is the case that the number is an abundant number, otherwise it is not. It's that simple. Now let's try to run it. I'll create a problem and let's give input 12. We know that 12 is an abundant number. It will give 12 as an abundant number, because if you try to find the factors, let's say 1, then you have 2, then you have 3, okay, then you have 4, then you have 6, okay, and after adding all those factors you will get less, I think 16 as a sum. So 16 is greater than 12, so you will get 12 is an abundant number. If you give something like 15, so 15 is not an abundant number. Now it's your time to do the code. Thanks for watching.